Well, I've been doing a little bit more experimenting with this electrical therapy unit, whatever it was called. Very old therapy machine, and I've been making some progress in investigating and seeing what to do. So let's just try and sum up where I am so far. If you look here, that is the mains transformer. So with the 240 volt mains goes into there, mains transformer. From there it passes out through this valve here, this rectifier valve. After it's passed through that rectifier valve there, which I hope you can see, the top valve, it goes to the first part of this condenser here. This is an 8+8 microfarad smoothing capacitor, or condenser as they used to be called in the old days. So it goes to the first part of that, then it passes through what they call a choke, smoothing choke, and from the smoothing choke it goes back to the second half of that condenser, capacitor, or whatever you call it. So that is the electrical part. Mains transformer, rectifier valve, smoothing capacitor, smoothing choke, second part of capacitor. So all that there has now been replaced, and I'll show you what we're using on the breadboard prototype. This is a piece of plywood which I'm experimenting as my prototype. So all that which we've shown you so far has been replaced by this single battery, one PP3 battery. That battery is now replacing all those components. So the next component that we needed was something to give us the variable frequency vibration, or alternating current. And to get the alternating current, we use this little thing here, which we've mentioned before. We'll turn it around so we'll get a better look at it. That bimetal strip in the mid picture here, there, that converts the high voltage DC into an alternating current with the bimetal strip heating up, and that is controlled by a variable resistor on the front panel, and that variable resistor here controls the frequency of the vibration and thus the alternating current. On the experimental breadboard version, that component that gives us the AC is replaced by this integrated circuit, little tiny blue board which contains an NE555 integrated circuit. There's also an LED which lights up when it's on, and that's the equivalent of the light we've got on the front panel of the therapy machine. And the control to change the frequency of the vibration is one of these little square blue gadgets on the board. You turn that at the moment with a screwdriver and that alters the frequency. So that's the equivalent of what we've got on the large board. But it will be changed around eventually. One of those little square blue variable resistors will be replaced with a proper one on the front panel eventually, and the little red LED will move onto the front panel as well. But that's simulating that. So after having generated the alternating current in the original therapy machine, we then put it through this triode. That is a triode valve, and we use that to give us the high power switching. So we've got the alternating current goes onto the grid of that, and that gives us our high power switching of the electricity. So high power switching there, and we replace that on the breadboard experiment. And what we've replaced it with is probably a bit hard for you to see, but it's a little transistor. We've got a transistor there, that black thing, and that is replacing the valve. Again, triode valve, triode transistor in a way, 3 connections, 3 wires. Then the final thing that we've got is the small output transformer here, and that transformer is replacing a transformer on the therapy machine, which I'll turn it around so you can see. And there on the therapy machine we have that long brown coil, and that is the equivalent of the output transformer on the little bit of breadboard. So they're both doing the same sort of thing, but it's all very much trial and error at the moment, and I may have to make a few changes. I think possibly the transformer I'm using is a bit too large for the job. More experimenting needed there, because at the moment my little unit is putting out 500 volts, and I think that is a bit high. Of course, I don't know what voltage the old antique one put out. No idea, no way of checking it. But my breadboard experiment is doing exactly the same thing now. It's giving us variable pulses, 500 volts, powered by a little PP3 battery. So eventually, all that can go inside the antique case and replace all the valves and dangerous electrical bits. So that is the progress at the moment. Therefore, all that you can see there, which is very, very heavy, extremely heavy, and of course dangerous with the voltage, is now being replaced by everything on this little board. So there we have our little board, a PP3 battery powering a little blue PCB, a transformer, and a transistor wire between them, and that is doing everything that the antique is doing. And of course much safer running off a little tiny PP3 battery than running off the mains. And as I said, it's possibly putting out a little bit too much, because my oscilloscope is reporting the voltage as higher than 500 volts. Well, we will see. At least I'm making progress, I'm getting towards it, but it's going to be a long, slow job, developing the necessary electronics and testing it for safety. But we are making some progress, and we're getting there. Thanks for watching.